Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, so to reiterate, probability of number one, area of the shaded over area of the total. So remember, probability is what you're looking for over the total number of outcomes. So area of shaded is 28, area of total is 40. So reduce that to 7/10, you're good. Number two, so you're gonna take the first term in that binomial and you're gonna, the exponents of that first term are gonna go down and the exponents of the second term are gonna go up. And then you're gonna follow this pattern because this is your Pascal's triangle. So that's the fifth power one. Remember the first row is 0 power, 1 power, 2 power, 3 power, 4 power, 5 power, okay? So next coefficient is 10. So then my exponent for 3r is gonna be the third. And my exponent for -2 is gonna be 2. Okay, another 10. Exponent for 3r is gonna be 2. Exponent for -2 is gonna be 3. Another 5. Exponent for 3r is gonna be 1. An exponent for -2 is going to be 4. And then one last one, 1 times exponent of -2 is going to be 5. Okay, so we're going to do the math here. So 3 to the 5th power, what is that? 81 times 5. What's 81 times 5? 405, right? So 405 r to the 5th plus, let's see, 81 times another 5 would be 405 r to the 4th times -2. I forgot that. So -810 r to the 4th plus 27r cubed, but times 10 is 270 r cubed. Oh, times negative, oh, I keep forgetting that. Times 4, what's 270 times 4? So that's 54, so 1080. R cubed plus, let's see, 9 times 8 is -72 times 10 is -720 r squared plus 16 times 3 is 48 times 5 is 190. Negative or positive 190 r, I think positive 190, and 16 times 5 is 90, no. Yeah, that's not 190, what is it? 16 times 5, come on, 16 times 5 is 80 times 3, so 240. 240 r, and then 2 to the 5th is 32, so negative, so -32. So that would be your crazy answer, okay? So if you're stuck on this, watch the video again. Remember, you're just taking this binomial 3r minus 2 to the 5th. So you're going to take this guy, and the exponents are going to go down. And this guy's exponents, don't forget the negative part, are going to go up. And then you got to use these coefficients because it's all to the 5th power. And that's the 6th row in the Pascal's triangle. Okay? That's number crazy 2. Number 3, domain and range. So you're going to find the vertex of the parabola, and so that'll kind of give you either the maximum or minimum of it. Do you guys know how to find the vertex of the parabola?
Graph it and then find that. Like without graphing?
Yeah, without graphing. You could graph it if you wanted to. But the vertex is going to be negative x equals negative b over 2a. So the x value of the vertex is going to be negative b over 2a. Well, in this case, a equals negative 1, b equals 0, and c equals negative 3.8. So this is going to be 0. So your x value is going to be 0. Okay? So then when you plug in 0 for x, you're going to get your y value. So when you plug in 0 for x, you're going to get negative 3.8. So this is your vertex. So this is what it looks like. 0 comma negative 3.8, 2, 3, 4, and it goes upside down because it's a negative x squared. So this is what your graph is going to look like. If you don't remember any of that, you can just plug in values. Plug in a bunch of values and see what you get. And then you'll start to see the shape of the parabola. The important part is for you to find the vertex, where it mirrors itself, okay? So let's see, what's the domain? Domain, remember, is the x values. So where do the x values go from?
It's all real numbers.
Yeah, it goes all the way left. This arrow means it keeps going left, even though it gets not as extreme, but it still goes to infinity, which is crazy to think about, but it happens. Okay, x values, they're negative infinity to infinity. So you can say all real numbers. What about the range? These are the y values. Where do the y values start and stop?
Y is less than 3.8.
All right, but I'm going to say less than or equal to negative 3.8. Okay, nothing above negative 3.8. It's all negative 3.8 and below is where that graph is. Okay. I'm used to interval mode because that's how you answer your questions on, like when you're doing math at Red Rocks, you have to use interval mode, so it's different, but this is easier because you can spell it out. X values all real numbers. Domain, or the range, is where the y values are, so they stop here. Okay. All right, you don't have to find the vertex. I think that's just part of the help that they give you. You don't have to do that. Okay. Number 4. All right, number 4, solve the equation. You can just use the quadratic formula, but first you have to put it in standard form so you can figure out what a, b, and c are. So just get that constant over there. So minus 7 equals 0, right? That's what I did. So now your a is going to be the coefficient of the x value, which is 1. B is going to be the coefficient of the x squared value is a. The coefficient of the x value is negative 4, and the constant is negative 7. So far, so good. The hardest part about this problem is being able to recognize what a, b, and c is. Okay? Because everything else is just plugging and chugging. So negative b plus or minus, so negative 4 plus or minus the square root of negative 4 squared minus 4 times a times c all over 2a. So this is me just replacing a's with 1, b's with negative 4, and c's with 7. Okay? This step you don't really need to do because, well, parts of this step. Negative 4 is just 4. Plus or minus the square root of 16 minus negative 28 all over 2. So 4 plus or minus the square root of 44 all over 2. So far, so good. If you get that far, you're awesome. But you're not done yet. And it doesn't really say simplify in simplified radical form, but how do you write square root of 44? Well, that's just the square root of 4 times the square root of 11, which is 2 radical 11. So then you get 4 plus or minus 2 radical 11 all over 2. And you can cancel, though, you can reduce that to basically 2 plus or minus radical 11. So that's a nice simplified version of it. All right, number 6, moving on. So when did we cut out, Silas?
I think you cut out around number 3. I think.
Okay.
You've been out for a while.
Shoot.
I've been sitting here not knowing what to do for a while now.
Okay, sorry. Okay, so number 6, we'll try to revisit 4 and 5. Cost varies directly as the number purchased if 8 items can be purchased. So basically cost varies directly as number purchased. Okay. So, or you could say, see, they give that other equation, but you could say C cost varies directly. So just a straight multiplication problem with K times number purchased. Okay, so first scenario. So you can write this down into scenario 1 and scenario 2. Scenario 1 says if 8 items can be purchased for $28. So 28 equals K times 88. Then how much could be purchased, or 44 items, what does that cost? So C equals K times 48. So we need to figure out what K is. So K equals 28 over 8, which is just 7 halves, or 350, 3.5. So we don't worry about money right now. So C equals 3.5 times 48. So what's 3.5 times 48? You guys have that calculator? Just keep that calculator handy so we don't have to go back and forth.
168.
So $168 even. Okay. So there it is. So figure out what your scale factor it is, or I mean, basically you could just figure out how much they're, I mean, this is, you can figure this out in pre-algebra, right? But let's go on to number 7. Trigonometric ratios, write this down. You can use this. So, remember, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Okay, so here's a 30-60 triangle. You don't need any of that, though, because this is a 30-60 triangle, right? So if the short leg is 14, S is going to be 28. Don't scare me with the trigonometric ratio thing. So S is just 28. Remember, the hypotenuse in a 30-60 triangle is always twice the short leg. But if you wanted to do trigonometry, you could say sine of 30 equals 14 over S. Okay? Because sine equals opposite over hypotenuse. If you multiply both sides by S, you get S times sine of 30 is 14. Well, sine of 30 is just 0.5. So S times 0.5 equals 14. Divide both sides by 0.5 and you get 28. Questions there? Does that feel all right?
Sure. I'll just do test questions.
Do you not know how to do that one?
No, I do. I just don't have a lot of faith.
Well, just remember 30, you could write this down too, on a 30-60 triangle. If this is x, this is going to be twice that. And this, remember, is that radical 3. If it asks for that, instead of multiplying by 2, you're multiplying by radical 3. You guys know what that's from? Original Batman, Danny Elfman Batman. Because Hans Zimmer didn't do the three notes. He just did 2. Da, da, because he wasn't a hero when Batman began. So that was his reasoning behind it. Pretty fascinating. All right, number 8. Factor. Oh, yeah, thank you. Factor by grouping. Ooh, so this is that you can just take a couple terms at a time and factor them. So we're going to factor these two. What factors out of both of those? Just an x squared, right?
Yeah.
So you get x plus 6. What factors out of both of these? 5. And you're left with an x plus 6. And look, they both have an x plus 6. So let's factor out an x plus 6. And you're left with x squared plus 5. That's nice. You could have done it any way you wanted. You could have factored these two, and it still would have ended up with this. It's pretty fascinating. All right, number 9, a number is chosen at random from whole numbers 11 through 30. From 11 through 30, so including 11 and 30, how many outcomes are the event? Choose a perfect square or multiple of 7. Oh, how many outcomes are in the event? Choose a perfect square. So this is a probability of perfect square or a multiple of 7. Or a prime number, okay? Or a prime number. So we're going to go probability of square plus probability of multiple of 7 plus probability of prime okay, and then minus probability of the overlap, okay? Probability of the overlap, if there's any, okay? So how many perfect squares are between 11 and 30? Well, 16 and 25, right? So just 2 out of what's our total?
19.
2 out of 19 plus, is it 19? I think it's 20.
From 9. Oh.
It's 20 because you're including 11 and 30. Stinkers. Okay, so plus multiples of 7. How many multiples of 7? You got 14 and 28. You just got 2, right?
Yeah.
So 2 out of 20 again. How many prime numbers? Well, okay, you got 11, 13, 17, 19, 23, and 29. So 6 out of 20. Okay, now we can forget about the overlap of multiples of 7s and primes, because if it's a multiple of 7, unless it is 7, it's not prime, right? The 7 can go into it. So let's just look at the overlap of prime and square. Well, there's no overlap of prime and square. So now just the overlap of perfect squares and multiples of 7. Anything exists there? No. So you're done. So that is 10/20ths, which is 1/2. Does that feel all right?
Yeah.
Okay. There, I don't know if the real test will have overlap or not, but that makes for an easy probability question. Okay, investigation 6. You know what that
Is
means.
this extra credit?
Extra credit.
Oh, yeah.
All right.
Are we actually
Number,
doing it this time?
what's that?
Are we doing the extra credit this time?
I can, if we have time, I can look at it, but we probably will not have time.
Well, I never.
All right, number 12, a cheetah.
Wait,
Oh, yeah, number 12.
11?
11.
You skipped 11. Then you
Yeah.
skipped 10.
Where is 10?
Yeah, it was laid out weird. It went
There's 10.
Oh,
10
okay.
and then.
I was like, where did 10 go?
Okay,
Yeah.
There we go.
11
is extra credit.
Okay.
all right. You can FOIL this out if you want, but it's just 64 x squared minus 9y squared, right? Because this is a difference of 2 squares. When you factor difference of 2 squares, it's plus, minus. So the middle terms will cancel. If you FOIL it out, you'll get like negative 24xy plus positive 24xy. That'll cancel. But this is what you end up with. So if I see a number multiplied by its conjugate, then it's just the first term squared minus the second term squared. That's it.
Yay.
Okay. All right, number 12. Cheetah can run blah, blah, blah per second. What is the speed in miles per hour? Okay, so we're going to just convert. Wow, this is like algebra 1. Feet
Yeah.
per second. So we have to change the feet and we have to change the seconds, right? So these are unit multipliers. This is why unit multipliers are why I've been bribing you and getting you to do unit multipliers, because it makes these problems really easy. So first thing we got to do is get rid of the feet. So how do you get rid of feet? We're going to go to miles, right? So,
What is it? 5280? Yeah.
so 5280 feet to 1 mile. All right, and that's done. That'll take care of that. We're done with our miles. Now we got to get rid of seconds. So this is where my brother's explanation of it is a little weird, because usually the top is where you want to go. And the bottom is, you have to leave it in the past, right? Which works if it's not a rate. But this time we have to change that. So now the bottom is what we want to go. So seconds to hours. Well, you can do minutes to seconds first. So 1 minute, 60 sec. No. Where you want to see how it kind of throws you off there. So 60 seconds. You've got to do it so they cancel, right? So 1 minute. And then you got 60 minutes and 1 hour. So now those will cancel.
Did you just do it by 120?
By 3,600, yeah.
3,600, yeah.
Yep.
That's the number I was going for. Oh.
So 104 times 60 times 60. If you just leave it like this, I'm fine with it. Miles per 5280 hours. Okay. So if you leave it like that, I'm fine with that. But you can multiply it out if you want to. They might multiply it out. I don't know. I don't know why they never did in Algebra 1, but it's weird. All right, fractional exponents, no problem. But before we even do that, we don't even get to work with fractional exponents, right? Because how do you deal with powers raised to powers? What do you do with the exponents when you have exponents raised to other exponents? You just multiply them, right? So what's 1/6 of 24? 5 to the 4th. That's it. So then that's 625. Oh, it even tells you to multiply the exponents. How lame is that?
Okay.
But you could have done it like this, the 6th root of 5 to the 24th. That would have been difficult and might have broken your calendar, or not calendar. What do you got? Calculator.
Spending so long.
See, I'm stressed for time, so it's subconsciously messing me up here. I still want to try to go back and do 3 and 4 again. Okay, number 14. So I see radicals in the denominator. What do? What do?
No. You just add a radical to the bottom, or to cancel it out.
You can't cancel it out, but
Square it.
you multiply by its conjugate. You can't just square it.
Isn't that squaring it? No.
No, because if you square it, it won't help you. You'll still have radicals. Whatever you do to the bottom, do to the top. So here's the deal. Avery, if you just had one radical in the bottom, you could have just squared it. Okay, but you have you have two things being added or subtracted, so you have to multiply by the conjugate. Okay, the conjugate is just turning that subtraction sign into an addition sign.
I'll just switch.
All right, so you can FOIL this out if you want to, but what we learned from number 11, I think, or number 12, I can't remember which one, or number 10, was it's a difference of 2 squares. So you just square that and square that. So this is just 7 minus 2, because radical 7 times itself is 7. Radical 2 times itself is 2, so 7 minus 2. Well, this is on top, you get 3 radical 7 plus 3 radical 2. So final answer, simplified answer is 3 radical 7 plus 3 radical 2 all over 5. Okay, you can FOIL it out if you want to. You would have gotten a positive radical 14 minus radical 14. Those cancel, and you're left with 7 minus 2, which is 5. Okay, number 15. All right, these are complex fractions. We have to get one fraction on the top first and a fraction on the bottom, and then we can copy dot flop. Okay, so how do you add a fraction and a whole number? Well, you need a common denominator. I mean, you could just do an improper fraction, but that's probably a little too complicated. It's easier, but it's harder to remember. So what's my denominator of this 4? 1. So what's my common denominator? Just A. So I'm going to make this an A, and whatever you do to the bottom, do to the top. Everybody okay with that? All right, over here, I need a B. So I'm doing that. Everybody okay with that? Okay, so add these. You get 3 plus 4A over A all over 5B minus 2 over B. So far, so good? This is a division problem. Copy dot flop. Copy dot flop. So 3 plus 4A over A dot B over 5B minus 2. Nothing cross cancels. So just squish them together. Don't forget parentheses around that binomial there. All over A over 5B minus 2. Call it good. You're done. Okay, you can multiply it out if you want. 3B plus 4AB over 5AB minus 2A if you want, but you can leave it like that. Okay. Okay, anybody have a unit circle handy? I do. And if you guys are at home, Silas, make sure you can use this on the test for sure. So here's my unit circle. And it says, where is it? So the sine of 225. So 225, remember the sine is the y value. Okay, so at 225, which is right here, what's the y value? Negative radical 2 over 2, you're done. That's what the beauty of the unit circle. So at 225 degrees, the second coordinate in that coordinate pair is negative radical 2 over 2. So you can use this diagram. I put it in one of the lessons, but I think I put it in the classroom resources as well. Unit circle diagram. This is beautiful. That's it. That's all you have to do. Can't get much easier than that. Negative radical 2 over 2. Okay, 17. Solve using something. So you can use elimination, substitution, combination of the two, whatever you want to do. Let's see. I'm going to get one of those y's by itself and then plug it into the other two equations. So let's see here. I'm going to get that bottom y by itself. So y equals negative 5x plus z plus 18. Okay, so I got the y on the bottom by itself. Everyone see that? So I threw everything else over there, negative 5x, positive z, minus 18. So this is what I'm going to plug into the other two equations.
Is it minus or plus 18?
Plus 18 because 18 is already over there, so you don't have to move it to the other side.
Oh, yeah. Okay.
Okay, so the top two equations, I'm going to replace my y's with this. So 3x plus parentheses negative 5x plus z. I don't need parentheses because I'm adding it, so it doesn't matter. Plus 4z equals 2. The next equation is 2x plus negative 5x plus z plus 18 minus 3z equals 13. Okay, let's combine some like terms. We get negative 2x, and then you got a z and a 4z, so 5z equals, bring that 18 over and it's negative 16. Combine the 2x and negative 5x, so negative 3x. Those parentheses are now confusing, aren't they? Because it looks like we're distributing, but we're not. It's just being added. So then you got your z here combined with a negative 3z, so that's negative 2z. Bring the 18 over, and that's a negative 5. So now we've got an old school equation that is pretty solvable. I'm going to get rid of the z's since they're already opposite signs. I'm going to multiply the top by 2, and I'm going to multiply the bottom by 5. Okay, so multiply the top by 2, you get negative 4x. You guys remember doing this? This is elimination. You can use substitution again if you want, but you'll have fractions, and nobody likes fractions. Sometimes it's the lesser of two evils, I guess. Negative 15x minus 10z equals negative 25. So then when you add them together, the result equation is negative 19x equals negative 57. So x equals a positive 3. So now you can work your way back up, figure out everything else. So if x equals 3, that's negative 12. So z has to equal negative 2. All right. So z equals negative 2. Let's just make sure it works in there. Negative 45, positive 20 is negative 25. Good. All right. And then plug it back into here to find your y. Negative 15 plus negative 2 is negative 17 plus 18. So y equals 1. So you can write your answer like the cool kids, 3, comma, 1, comma, negative 2. Or you can leave it like that. That takes a while, but it's all doable stuff. There's multiple ways to do this problem. You don't have to do it exactly like this. You could even use elimination to get rid of y's, but you have to keep track of which equations you're getting rid of y's, so it makes it a little more complicated. So I think substitution is the better way to go, at least for the first step. Yes?
Where'd you get negative 2?
Negative 2 right here.
Oh.
So I just plugged it into one of these equations where it was just x and z, because I plugged my x, 3, into one of those equations. Okay, so just kind of work your way back up. All right, number 18. All right, number 18 says solve negative 8x squared equals 288. Write the solutions in terms of I, okay? So what do you want to do? Doesn't look too difficult so far, right? How do you get x by itself? You don't even have to solve by factoring.
Would you divide?
Yeah.
-8?
Yeah, divide by -8 first, and then you're left with x squared equals a negative. Let's see, that goes in 36 times. Oops, I'm not square rooting it yet. So now how do you get x by itself? Square root it. So x equals the square root of -36. -36. So what's my answer?
3, 6.
-6
-6. -3.
or 6i.
6i
There we go.
or -6i. So it's positive or negative 6i. So the negative sign becomes an I, and the 36 becomes a 6. When you try to take the square root of a negative sign, you're going to poke your eye out. When you try to take the square root of a square, it's whatever that is. Okay, so technically this is the answer. Positive or negative 6i. Don't forget that positive or negative. When you take the square root of something, there's always two things. All right, number 19. A mass of iodine, 131 atoms decays in such a way that okay, so this is the half-life thing. How did we do this? Solve for y equals a, b, and then for b. Okay, then substitute 32 for x. Okay, so it tells you how to do it. So we're going to write our equation, y equals ab to the x. So we're going to solve for b. Okay, how do you get b by itself? Well, you have to get rid of a, right? Do we have a 131? Well, let's solve for b. So b to the x equals y over a. So if you take the x root, I forgot how to do these.
Can you just be extra credit then?
Yeah, let's make it extra.
I just did, I divided 32 by 8, and then which came out to 4, and then you just divide, I just split it in half 4 different times.
Yeah,
So it came out to 1/16.
yeah. So and you know, it starts, it decays. So b to the 0 would be 131. So that's how you can determine that. So b to the 0 is 131. So y equals a times 131. Or no, y equals a at b to the 0. So you could do it that way too. So let's just make it extra credit and call it good. Number 20, write the exponential equation blah in logarithmic form. So 12 to the 0 equals 1. How do you write this in logarithmic form?
Log 12, 1 equals 0.
Yep, so the way you would say it is log base 12 of 1 equals 0. Okay, so you say
And
base.
would you need the 1 because it's just 1? Could you get rid of it?
Well, I mean, that's how you would write that in. Now you can, obviously, you already know that 12 to the 0 equals 1.
Wait, is that a -10 or g, whatever that is?
It's log, and then the little 12 there. Yeah, that board is kind of messed up there.
Negative 10g.
I actually made a mistake because I wrote a number right next to that and I thought it was negative, and so I made a math mistake because of the dumb board.
On a calculator, how do you put log as the base, or 12 as the base?
When you hit log, it should like give you either a parenthesis or automatically should subscript.
So on a calculator, you don't have to worry about that yet though, okay?
Okay.
So you just have to rewrite this translate it into this form. It's the same equation, it's just in a different form. Okay. All right, what do we got? So I'm gonna go over number 3 and 4.
Wait, is that all? That's it? That's the answer?
Yep, that's it. So you're just rearranging it.
Well,
So the base goes here, the answer goes here, and the exponent goes there. Okay, so we're just gonna look at just 1 through 4 really quick. So the probability of the shaded, so basically shade over total. So you're gonna find the area of the shaded over the area of the total. Okay, you can do the math. We did this in pre-algebra. Area of the shaded is 28. Area of the total rectangle is 40. So reduce that to 7/10. Okay, boom. Number 2, use the binomial theorem to expand. Oh my gosh. I think, we did this, right? We lost them at 3. Maybe I'll come back to that if there's time. Number 3, identify the domain and range. So you need to realize, well, you could say the vertex is basically negative b over 2a is the x value. And then y is going to be, when you plug x into that equation, you're going to, or whatever you get here, you're going to get the y value. Okay. So negative b over 2a is just 0. So when you plug 0 into that equation, for y, you get negative 3.8. So this is what the equation, this is what the graph looks like. So that's negative 3.8. That's where the vertex is. So what's your domain and range? Your domain, or your x values, goes from negative infinity to positive infinity. So all real numbers. Your range, which is your y values, starts here. So that doesn't go higher than negative 3.8. So y has to be less than or equal to negative 3.8. That's it for number 3. Okay, number 2, just so we have it all on one video. And then we did do 5. We had 5 at the beginning of this. Binomial theorem. So first I'm going to draw Pascal's triangle. Okay, so this is binomial a plus b to the 0. This is to the 1. This is to the 2nd power, 3rd power, 4th power, and the 5th power. This is the one we want. This is our binomial, 3r minus 2 to the 5th. So we're going to use these as coefficients. So it's going to be 1 times our first term to this power. So 3r to the 5th plus 5 times this term to the 4th power. But you're also taking the 2nd term, negative 2, to the 1st power. Okay? And then our next coefficient is 10. So that's 3r to the 3rd, negative 2 to the 2nd. So your 3r's are going down, the exponents, and the negative 2's are going up. Okay? Next is another 10. And then 3r's go down to 2, negative 2's go up to 3. Now we got a 5, so we got the 3r's going to 1, the negative 2's going to 4. And last but not least, you got 1 no 3r's because it's to the 0, and then just -2 to the 5th. All right, so do all that math. You get 1 times 405 r to the 5th. Did I say 405? Isn't it 81 times 3? That's 243. So I did it wrong on the video anyway, which is good because you guys catch that? Oh my gosh. Okay, so this is 243. And then you get 5 times 81, that's 405. R to the 4th, and then times -2, plus 10 times, let's see, 27 r to the 3rd, and then +4, plus 10 times 9r squared times -8, plus 5 times 3r times +16 plus -32. Okay, so do all that math. You should get your answer here. Maybe I'll do it 243 r to the 5th plus a big number. So that's -10 times 405, so -4050 r to the 4th plus, let's see here. So 108 times 10 is 1080 r cubed plus -720 r squared plus 240 r minus 32. Lots of details, lots of opportunities for mistakes. Be careful. All right, that's number 3. We already did 1 and 2. Number 4, you're just plugging in A's and B's and C's, so you have to get it in standard form first. So x squared minus 4x minus 7 equals 0. So A equals 1, B equals -4, C equals -7, and then plug it in. Negative B, so -4 plus or minus the square root of B squared. So -4 parentheses squared minus 4 times 1 times -7 all over 2A. So then that's +4 plus or minus the square root of 16 minus 28 all over 2. So that's 4 plus or minus the square root of 44 all over 2. Square root of 44 is just the square root of 4 times the square root of 11. And that's just 2. So then you get 4 plus or minus 2 radical 11 all over 2. Well, you can reduce that 2 with both of those 4 and 2. So you get 2 plus or minus the square root of 11. That's it. All right. Hopefully we got everything covered.
Yeah.
Flack math! Give me some math and I'll give you some flack. Flack math!